Good morning, good afternoon, good evening, wherever you are. It's a very special, very special episode of LMTV today. This is called the LMTV WTF, which had meant different things at different time. But today it means, where is Tony Fortunato? And guess what? We actually found him in the place that he rarely visits, which is his home. Good afternoon, Tony.
Good afternoon, Denny. Hey,
And,
Tim.
and good afternoon, Tim.
Good afternoon, everybody. Hope everybody's
So
well.
the idea, and correct me if I'm wrong. The idea of WTF is that, at least that was my original thought, is that Tony has created such an immense library of educational videos, everything that you wanted to know but afraid to ask about networking. And I thought, well, wouldn't it be nice if we could, just create a forum where we could kind of talk about this and maybe introduce some new perspective, and especially when Tony's on the road working on new problems. So that's the kind of the idea. But Tony, you take it wherever you want to take it. It's your show.
Sure, thanks. So what I did was, when Denny and I chatted back and forth about this, I thought, what can we start the session off with? And I just happened to be working on a problem, and it happened to be talking about Icmp Redirects. Now, I always say Icmp is kind of the that little protocol everybody takes for granted. You know, everybody will ping with it or trace route with it, and that's it. What a lot of people don't understand about Icmp is it may be running in the background all the time on your network, helping your applications, helping your performance. And one day when you make a network change that stops Icmp from going back and forth, that application now times out, or the performance suffers, and it seems like the problem came out of nowhere. But you know what? The problem's never gone away. It's always been there. It's not a problem. Icmp has been helping things along. And this is an example of an Icmp redirect where Icmp is actually helping something get along. Now, as I talk about this, I'll just briefly throw in some talking points that people have given me some good feedback on about Icmp, because this can go 10 different ways. So I'm going to start with the presentation. We're not going to play the video. You can watch that, but I'll show you the slides from that and a trace file from that, and I'll take it from there. So I'm going to screen share.
Yeah, and while Tony is doing that, for those of you who are this is a brand new show, so a lot of you might not know, but if you're watching live, there is a way to ask questions. Go to the left-hand edge of your screen, click on Q&A, and that's where you can ask questions. Now, normally Tony charges a lot of money for answering questions like that, but today he's giving us a break. Free is good, right, Tony?
Yeah, you get the family discount.
Yeah.
Yeah, well, actually, the way we got a discount is he's snowed in. He can't get out.
All right, so here's the couple of slides right from the video that you can catch. These are the packets going back and forth, and this is a good old ping. One of the things that I posted is a cool article about something called a routing audit, and this all kind of goes back into the same story. So this first packet is good old ping, and this is what people do on the internet every day. They send this little ping request out, and the very next packet you see that comes back, the source is this 10.1 guy, whereas the destination was this 10.99. So that's not the destination replying. This is somebody else saying redirect, and this is the router. There's a router coming back saying, you know what, there's a better way to get there. Now, what this means to you at your desk is nothing. Your pings will still work, you'll still get a response time, and things will work. You might notice the first ping's a bit slow, but again, some people will chalk that up to just regular network behavior. So the very next one, packet 3, you'll see the destination is now the same, but the source is 119. So now there's your good old reply. So it's kind of a little bit of a handoff, and on the next slide you'll see it a little bit clearer. But the goal of this first slide is to simply show you what people think. I've got a desktop here on the left, I've got a server here on the right, and I've got a good old switch in the middle. What can possibly go wrong? That's literally what the client said to me. This is easy. And when I said, let's just do a quick Icmp baseline, they said, oh man, what a waste of time. Don't you have anything else to do? I said, you know what? If you did a baseline or a check and it came back positive, that's not a waste of time. If you went to the doctor and used a stethoscope on you and didn't find a problem, guess what? That's good, right? That's not a waste of time. So I always say that there's never a waste of time. But what we found was this Icmp redirect happening. So here's what it looked like. And you can see that very first packet now in this graphic. And he's going out, he's doing his little ping request. There he goes. So he's trying to hit this guy on the top, and there's the switch. But they forgot all about this router that they had, because the router is only used for one thing. It's used for internet access. So they're thinking, well, who cares about that? We're not going to the internet. But guess what?
Tony just dropped off from, so he probably knows that, so he's going to log right back in. So there are a couple of viewers out there, so hang on just a second. Tony will be back. So this is why we named the title, we named the show this way. Where is he? There he is.
There he is.
Okay, so well, thank you for reminding us the title of the show, Tony.
Oh my God, that's so funny.
Okay, no, that's fine, that's fine. So Tim, remind Tony where he left off.
You're in Canada, Tony.
Yeah, it's the conversion that gets you. Sorry about that, guys.
No problem.
You were trying to find.
So did the cat tripped off on your Ethernet cable? Is that what happened?
That's right. That's my cat's fault. All right, let me get back to this before I lose my train of thought, which I think I've already done. Okay, so here we go. We got that packet. That first packet was going to the server, and unbeknownst to them, this default gateway on the right-hand side here got in the way, and he sent back a redirect. Why? Because the station in the bottom left-hand corner was configured with that as its default gateway. And guess what? It's always been like that. Guess what? It was part of a network migration. Guess what? Nobody's ever gone back to that computer to change its default gateway because it always worked. And I can't tell you how many times I run into this where people say, yeah, but it's always worked. What's the problem? And guess what? It is a problem, because one day, when you don't allow Icmp to move around your network, things are going to break. And I can't stress this enough. When I go through these little exercises with customers and we find that there's these little idiosyncrasies, it's not a big problem. Don't get me wrong. It's not a problem at all, but it's something you should be aware of. So when you troubleshoot, you don't think this is new. When it comes to Icmp especially, and this is, I'm going to kind of switch to my trace file here.
Hey, Tony.
Yep.
We're talking about Icmp v4, right? Not.
Yes, Icmp. Yeah, right on. Thanks, Tim. Yeah.
Yeah, because IPv6, Icmp is a big difference. Huge.
Yeah, it's a different minimal. Here we go. All right, so now you should see. Let me just see here. You guys should see my. You see my Wireshark?
Yep. See it up.
Oh. All right, in my previous screen I don't see it. Okay, so here we go. So you can see here at the packet level, and this is kind of the same thing I was showing you graphically, and you'll see the ping request, and you'll see the redirect. And what I want to do is not to get all geeky on people, but down here, when you get into the packet detail, and of course that's all under here, under packet details, you will see the Icmp packet. Now there's a little thing that I love to show people because I don't think it's that well known. Icmp version 4 is the only protocol that I've ever seen in my life that will actually include a photocopy of the original packet. So when you're trying to troubleshoot Icmp, or if you're doing a security thing and you want to find who really sent this packet, what was the cause of this Icmp packet, you can just come inside of that Icmp packet, and there's the original, in this case IPv4 packet that caused the redirect, the ping request. And it even tells you the source and destination. And I can't tell you how many times in my career I've shown people this, and they just think, wow, when did they just add that? When did that happen? Well, no, it didn't just happen. It's always been there. This is where the tools come in, because some protocol analyzers will only show you the Icmp header, and then this will say data. And they don't quite do the actual decode. So this is where you have to be a little more comfortable with your protocol analyzer and just pick any old Icmp, like a redirect packet or destination unreachable or whatever it happens to be, and see if there's the original IPv4 header and packet in there, which is a really cool little trick. Now, the other ICMP packet, because I'm kind of just going almost on a tangent here, but it's related, there's fragmentation, which could be an issue for people. And when we talk about fragmentation, something along the way might be chopping up this packet. And here's the fragment offset, and this is how the packets will track how do I reassemble these. So this is offset 0, and the next one might be offset 100, which means it's the next 100 bytes. So when you want to track that, again, you need to be able to look inside this header, and when you have fragmentation and it can't happen, you'll get back an ICMP error message saying, fragmentation required. Try this size instead. Again, not all protocol analyzers will tell you and decode that value, and you'll never know what that number is. So, like I said earlier, I said ICMP can go 10 different ways, and as you can see, that's pretty easy to do. But going back to the example here, I'm just going to go back here one last time with my screen share. Let's go back here, and I'm going to share this one last time. There we go. There we are. So now you can see, in this case, when you have and people say this is a simple network, and large networks are just like this, only multiples of the same design. So when you sit down, even at your desk today, just try pinging something and capture those packets. Chances are, I'm going to say 8 out of 10 times, it's going to work exactly like you thought it should, which means now you've gained knowledge in your network. I call that tribal knowledge, which means you know how things really work. So tomorrow when you have a problem and you ping something and it comes back with a different response or a different ICMP error message, you're going to say, wow, that's different. What the heck is this thing? And now you have something to run with. So I can't stress this simple example how many times this leads into like a Pandora's box of troubleshooting at customer sites. And I found routing loops, I found firewalls, proxies, I found gateways of last resort that aren't set right. I found so many problems doing this very simple exercise of pinging or trace routing, and you get back a wealth of information. So this is, I always say, this is a win-win. You can't possibly lose with this simple exercise. No probes to buy, no extra software to implement, and this is all based on the fact that you can actually ping something. Okay? On the flip side of this, if you did, we look at the same kind of diagram. If this switch in the middle, my layer 3 switch responsible for routing, if you said, oh, we are a secured company, we will not allow ICMP to move throughout our network, it's a bad protocol. Well, you better be careful. There's a lot of applications that require ICMP to move back and forth just to make it run. Now, if you did go ahead and block it, you might want to double check your apps to make sure they were working, or better yet, working as well as they did before your change. Conversely, if you did block ICMP, then pinging is very valuable because it should fail. For the security people out there, they might want to see, well, what kind of response comes back? Does the switch send back an error, which is bad? It should be quiet, and it just quietly discard the request, right? So again, simple pings can lead to a whole other conversation. Okay? So back to this. And I'm going to show you one last thing here. How are we doing, Denny?
We're doing great.
Okay.
Just a reminder, people who are watching live can, in fact, ask questions. Just go to the left-hand side, the left edge of your screen, and find the icon that says Q&A, and click on that. And then ask questions.
So we've got our, and you can see here, and this, again, not to get too geeky, but you can see ping request, the redirect, and the reply. We've talked about that already in the graphic. But the very next one, you can see request reply. And again, this is equally important only because if you ever do this test, you have to make sure you capture all the packets, all of them. Because if you had missed the first 3 and you had started capturing from here onwards, you'd see request reply, and you'd say, oh yeah, everything's fine. So make sure, and I can't stress this enough, you have to get things set up properly. And I've seen this a million times where somebody opens up a screen, starts pinging, and says, oh, I forgot to run my capture, and then they hit start. You probably missed the most important part of the conversation. When you get more comfortable with protocol analysis and you capture these packets, you'll look at this and say, oh wow, we're missing stuff already. Like what? Like at the ARP, the ARP. I'm ARPing, like I got to get off my network somehow. I got to find this thing because they're on different subnets. And oh yeah, right, I missed that. Well, why is that important? Well, again, from a security standpoint, you want to make sure there isn't something as simple as a man-in-the-middle attack, or something's not configured right with proxy ARP, that kind of weird stuff. Again, every packet has a purpose. You know, I've always said that. If you don't know why they're there, just find out. It's a simple Google search, or go to my site, or whatever. There's millions of ways to find a resource to answer the question. Again, the beginning of this conversation, we had the request, the redirect, and the reply. The best part about this is when it starts working, request reply, you can actually validate the response time. And you can see in this case, 0.001. I don't know how good your resolution is on your screen. That's 1 millisecond. So I know how long it took for that to come back now. Then I can see the half-second ARP goes out, and then you get your ARP reply, which again, you have to understand, when does it ARP? When does my cache time out? Again, should I be ARPing for this? Should that device be responding to the ARP? Should it be a router? That sort of thing. And then so on and so on and so on and so on. And then once you get your eyes used to it, everything becomes a pattern. And you'll notice the pings go out every second. Why? That's the Microsoft default. What if I use Linux? What if I used Android? Yes, yes, they'll all be different. Yes, that's true. Now here's a neat little tip when you look at a reply. When you look at a reply and you open the IPv4 header, there is something called a time to live. Now this is a neat little thing I talk to people, because sometimes you can't ping something because it's being blocked or firewalled and that sort of thing. Well, a little trick is if you capture the packet on its way back and you know what it started with. For example, these two machines are Microsoft, and I could see the request go out, and in this case the time to live is 128. Well, the guy who's sending me back the ping reply is also starting at 128, and when I get the reply, it's 127. Therefore, I traversed one hop, one router. That's incredibly important. When you don't know the path of the network because you can't do a trace route, here's a way to find out. Now, the best part about it is once you know that's 127, now you can actually look at that time to live and see if the routes are changing. And I've seen that. 127, for example, then 126, and then 127, 127, 125, 127, and that's your network flapping. It's taking a route, it's taking another route. And I've been in many examples where people have said there's only 2 routers between us. In fact, there's 6 hops because it's taking the long way around. And this, again, leads to what kind of routing protocols are you using? Are they link state? Are they static? All that kind of stuff. Again, this could go a whole other conversation. But the time to live is a great little tip when you have a packet coming back to you. As long as you know what it started with, you'll know how many routes it traversed. And there you go. So a little bit about ping request, ping reply. Again, if you do want to track this relatively easily in Wireshark specifically, you can right-click on this, and then you can actually make this a column. When you click Apply as Column, I hate that term. It should really say Add as Column. And now it's going to add. See the time to live here? See that? So now I can just visually look at that really quick. And when you combine that with a simple filter, you can find out exactly how, I always say, how stable the route is. And you can even see here in the redirect, this is kind of neat. It gives me 2 numbers. So it tells me that the first one, 255, that was the device that sent the redirect, the actual router. And then that second one was the actual real source, was 127. So you get, again, a super fountain of information by simply looking at a simple ping. All right. So I'm going to go back to me, and there we are. So I hope that helped. Again, some of this information was not in the original video, but I was taking a look at some of the feedback I got, so I thought I would try to address some of those questions that people had posed to me. Again, part of a network cleanup, part of an assessment, part of your audit, part of your troubleshooting, part of learning your network. I can't tell you how many times I've done this, and I've gotten more comfortable on people's networks than the people who worked there for 10 years have. Again, baselining, it's a good baselining tool. And please be careful, future network changes can easily impact applications that require ICMP. And a lot of times you have no choice. ICMP is working in the background and it's making things work for you. And that's it, folks. So I guess, Mr. Denny, what do you think? Was that a good stab at it?
That was good. That was good. I think it does exactly what we had in mind, right, Tony? Kind of gives that the context to.
Yeah, Tony, this is great, Tony. I mean, helps people. You know, half the time we forget to encourage people to play the stuff. And sorry about that.
Today's the day of the technical issues.
Trying to shut some people off. Yeah, I mean, it's really great to encourage people to play. And ICMP's pings are not dangerous. I mean, unless you get a ping flood going.
Right.
And that can happen if you don't know what you're doing. So, you know. But otherwise, it's great. And like you mentioned earlier, this is IPv4. ICMPv3 for IPv6 is a whole different animal.
Yeah, I should do one on that. That's a really good point, Tim.
Yeah, because it's a whole different animal.
Yeah.
Well, why don't we stop here? I think Tony and I have that experience that the longer the show, the less likely it is people will watch. So I think this is a good point to stop. Just one more comment: if you for whatever reason you couldn't attend live today, or if you attend live but you are not really alive to ask questions, or for whatever reason you're not able to express your view. Just go ahead and do that on the YouTube video. This show actually generated a YouTube video. You can comment on that, or you can comment on the original ICMP video, or you can comment on the Love My Two post. Wherever you put your comments, Tony would be the first one to respond, like he always does. Right, Tony?
Yep, that's my job.
Okay, so I assume that I'll see you again on this is working, right?
Mm-hmm. I think it's good.
Yeah, I like it. I like it. Okay, so with that, we're gonna sign off. Thank you, Tony, and go back to shoveling snow again. And, thank you, Tim. I assume you have less snow down south, right?
We didn't get any. We got a little ice. That was all we got.
Okay, all right. Okay, so with that, we're going to sign off, and we'll see you soon. Bye-bye.